Okay, folks, I just want to do a quick video for tackling some of these square root problems that also have more complicated inequalities that need to be solved. So let's go ahead and find the domain of this function right here. G of x is equal to the square root of 16 minus x squared. Okay. So I did something similar to this in the very first video, but I did it with logarithms. But we're going to use the same strategy. So for this problem, what do we want? Well, we want 16 minus x squared to be greater than or equal to 0. Okay. Well, what's gonna permit this to happen? Well, first of all, I think it's hard to look at inequalities when they are in expanded form, and it's easier to work with them when they are in factored form. So I'll go ahead and factor this, which gives us this expression. Then what I'm going to go ahead and do is I'm going to build an inequality, and on that build a number line, and on that number line I'm going to list all of the places where this inequality in factored form set to 0, not set equal to, in this case greater than equal to, but set to 0 on one side. I'm going to list all the places where this inequality is either 0 or undefined. Okay. So where is this inequality 0? It's 0 when x is equal to 4 or when x is equal to negative 4. So here's negative 4 and here is 4. I think I want to do that in a different color. Bear with me. So here is negative 4 and here is 4. Then what am I going to do? Well, this is what we did last time. I'm going to go ahead and pick up some test points, one test point on each side of these inequalities. So let's, I don't know, take for a test point maybe negative 5. That'll be easy to plug in. And let's pick 0 for x, and let's pick 5. Then I'm going to plug them into this expression here. I could plug negative 5 into the original expression here and look at its sign. Okay. But it's easier to put it into factored form generally. Maybe not so much in this case, but generally once you've got it in factored form, you might as well keep working with that factored form. So notice if I did 4 minus negative 5 times 4 minus 5, I'm not actually going to compute this. I'm just going to look at the signs of these two expressions. Well, let's see here. This would be a positive expression because we'd have 4 plus 5. This would be a negative expression, and of course the product of a positive and a negative is negative, which means no matter what I pick for this expression right here, I'm going to get a negative sign. Okay, so even though my test point was negative 5, had it been negative 6 or negative 7 or negative 4.5, no matter what value I pick, I would always get a negative expression when I do this, which means that this expression right here, this region right here, will always return negative values. Similarly, if I plug in a 0 into this expression, we'd have 4 minus 0, that's positive, and 4 plus 0, that's positive, and the product of two positives is again a positive. And if we plugged in 5, we'd have 4 minus 5, that's negative, 4 plus 5, that's positive, and the product of a negative and a positive would make any value that we pick from this region here, any value we pick, would result in a negative value. So now we return to the original inequality that we're trying to solve. We're trying to determine where is this thing greater than or equal to 0. Well, this inequality is greater than or equal to 0 for any values right here. Okay. So I think you should agree with me that since the choice of, we picked 0 and we plugged in 0, we got a positive number, and that would have been true for any value between negative 4 and 4. I think you would agree with me shading this line right here as part of my solution set. Okay. The other thing, though, we have to spend just a moment to talk about is the endpoints here. Why are those endpoints sitting on the number line? They were where the inequality came out to be 0. Do we want the inequality to be 0? Well, yes. We've written that this needs to be greater than or equal to 0. So unlike my last example with the logarithm, I am going to include these endpoints. So what is the domain of G? Here we go, our final answer. The domain of G is the set of values x such that x must be a real number and negative 4 needs to be less than or equal to x, which needs to be less than or equal to 4. Or probably better put in interval notation, the interval notation for the answer would be from negative 4 to 4. I hope this was helpful.